Howdy, this is a quick video on lesson 10.1. I want to talk a little bit about two different methods to solve systems of equations. So the first method is called Gaussian elimination, and Gauss came along and he said, look, if you can take a matrix and turn it into a matrix that with this as your goal, get it into what's called row echelon form, REF. If you can get it into that form, then you can think about it. There's a 1 here. You can figure out that this column represents your x's, this one is your y's, this one is your z's, and then you can use your back substitution to fill it in. So Gauss was rocking that. And then Jordan came along and he said, hey, you know what? We can make it even better. What I want to do is I want to make a series of row operations so that I have zeros in these other spots. Do you see in Gaussian elimination you have the 1s on the diagonals and zeros below it? But in Gauss-Jordan elimination, you have 1s on the diagonals and everywhere else are zeros, okay? And then your goal is over here. Your goal is the x, the y, and the z over here. And this is what's called reduced row echelon form. And if you look at your TI-84 calculator under the matrix menu, all the way over on math, scroll all the way down and you're going to have two choices, REF and RREF. And so you've got two different ways you can go. I want to point out number 79 to you. All right, so this is what we're keeping in mind. And we're going to try from your textbook number 79, which is a bit peculiar because you've got x plus 2y plus z equals 8. And then you've got 3x plus 7y plus 6z equals 26. All right, so stop and look at that. And right away, you know something's a little off. You've got 3 variables, but only 2 lines, 2 equations. So you're thinking to yourself, this is going to be a little bit different. Your first step is to turn this into a matrix. So we're going to make sure our x's and our y's and our z's are all lined up. They're good to go. So we're going to take that matrix, which would be 1, 2, 1, and then our coefficients, 3, 7, 6. I like to draw a little line. Ron uses little dots. I'm a messy person, so lines are good for me. 8 and 26 are our solutions, okay? So we need to do a series of row operations to try to get this 3 to turn into a 1. I'm sorry, to get this 3 to turn into a 0. So I'm thinking if I had a negative 3 up top here, I could do negative 3 plus 3. That would give me 0. So my first row operation, I guess we should talk about row operations too. I think you saw the video with Gabe and he did a few of them. So we're going to do negative 3 times row 1 plus row 2, okay? So that's going to be our first step. So I'm not going to change row 1 at all. It's going to stay exactly the same. Exactly the same. So I just recopy it. I'm going to take negative 3 times 1, which is negative 3, add it to 3, and I get 0. Negative 3 times 2 is negative 6, plus my 7. Oh, bonus. Look at that. I got a 1 there. I'm looking at my goal over here to get 1s on the diagonal and 0s below. Look at that. One step, I did 2 things. Yeehaw. Negative 3 times 1 is negative 3 plus 1. That's going to give me, nope, totally wrong. Negative 3 times 1 is negative 3 plus 6 is going to give me 3. Negative 3 times 8 is negative 24. Plus 26 is going to give me 2. All right, so stop and look at this. I cannot go any further. This is what's called row echelon form by just doing one step, which is pretty great. I can take this, let's turn it back into equation. So this would be x plus 2y plus z equals 8. And then I could take that second equation and turn it into y plus 3z is equal to 2. Well, I don't know about you, but I'm thinking that this would be pretty easy if I made this y equals negative 3z is plus 2, right? So I figured out what y is. So if I'm thinking about what my answer is going to be, I'm going to put over here x, y, and z. Y is y, all right? No, that's totally wrong. I'm going to turn it in over here, and z is z. And y is going to be negative 3z plus 2. I'm a little nervous. You know, this is my first e-learning day. And then I'm going to take this value of y and I'm going to plug it in to the y that I have in my equation. So let's see, I've got x plus 2 times negative 3z plus 2 plus z equals 8. We're still in the paper there? Scrolled up a little bit. And I can simplify this, so x plus negative 6z plus 4 plus z equals 8. Let's see, if I pull it all together, I can solve for x. So x is equal to, let's see, that'd be negative 5. So if I pull it to the other side, that's going to be 5z. And bring the 4 over, that's going to be plus 4. So now I've solved for x as well. So that's going to be 5z plus 4. All right, so I've gotten to come up with an answer. So Gabe did some really nice problems with you guys in on the online version of the textbook. And what I just wanted to point out, not every system is going to be consistent. And not every solution is going to give you one pretty set of answers. This one, number 79, we had dependent answers. To recap, you've got two different forms to solve: Gaussian elimination, Gauss-Jordan elimination. I personally don't care which one you use by hand. If I'm working by hand, I'm going to use Gaussian, and I'm going to get into this form and back substitute. If I'm using my graphing calculator, I'm definitely going to use Gauss-Jordan and use RREF. The command is on under the math menu. All right.